Hello, my name is Aidan Walsh, and this video presentation is going to examine the concept of flow and value streams and how to make the value stream flow. Let's start by looking at a presentation overview. So we're going to look at what is flow and explore the concept of flow, examine the importance of creating flow and value streams, and also some techniques for preparing for flow, and then finish with a summary. So let's begin by looking at what is flow. Okay, so let's look at what is flow and the concept of flow. So it's one of the most critical concepts of lean philosophy, and uh, it is very important to lean organizations. And what organizations will be trying to do is try to achieve flow in their value stream. And that's concerned with improving the flow of value-added activity between processes, whilst also limiting waste and weights between processes. So if you can imagine a water running downhill unimpeded, you've got a readily stream of flowing water. You want to try and imagine your processes like that. And the value add activity is like the water, it just runs seamlessly between the processes with nothing that stops or impedes or inhibits the flow. So you're limiting the amount of waste and weights between processes. And if you do that, then you improve the flow. So really what we're talking about doing here is eliminating obstructions to flow. The flow of people, the flow of products, the flow of services, the flow of information, or the flow of materials. So in simplest terms then, one-piece flow means that parts are moved through operations from step to step with no working process in between either one piece at a time or a small batch at a time. So the whole concept of one-piece flow is that as soon as one particular process step is finished working on that part or that work in process, that particular activity, it automatically moves to the next step in the process without any waiting time. So you imagine then you've got a steadily uninterrupted flow of work in process between each um, activity and the next activity, each process and the next process in your value stream. And then your process then appears to flow smoothly and continuously without parts waiting for operators or machines to become available, or operators or machines waiting to become available. Now I mentioned parts there, but it can be any partly completed activity. So it can be paperwork, it could be a customer request, anything like that. So you've got work in process and it's flowing smoothly and continuously without waiting for a particular process operator to become available or machine at a particular process to become available. Um, and really this flow should appear to be smooth and uninterrupted. When we need to think about improving flow, you've got to remember that flow is dependent upon all elements of our system working in harmony. So we need to work with customers to understand patterns of demand, to better understand how we can improve our processes and thus improve our flow in those processes. We need to work with suppliers because every organization is going to use some sort of input from suppliers in order to deliver their product or service. So we need to be able to develop dependable patterns of supply of materials and other resources. And we also need to work with the different processes in a value stream. So all the different, if you like, sub-elements of the value stream to enable this seamless, uninterrupted flow of outputs from one process to the next. So remember, each process receives an input from the previous step in the process. It transforms that input in some way and then delivers that as an output to the next step in the process. And what you want to achieve there is this uninterrupted flow of work in process from one step in a value stream or in a process to the next. So let's look at demand patterns first and what we can do to work with customers to better understand demand patterns. And again, this is critical to understanding how we can improve flow. So customers are absolutely critical to organizations. I mean, we don't really have a need for an organization unless that organization is serving a customer demand and doing so successfully. So in many respects, customers are the lifeblood of the organization. And because of that, then we need to understand customer demand, and understanding those demand patterns is critical to successful lean implementation. So customers will drive activity in an organization. And in order to better understand that customer demand, then organizations um, can use that information if they have this deep understanding of customer demand to enable them to streamline their scheduling activities, so how they schedule work happens, how they actually carry out that work in terms of manufacturing or providing a service, and then how we get those finished products to the customer or distribution activities. So in order to understand demand patterns, you really got to listen to what customers are saying. Try to figure out what exactly they need in terms of a value proposition from your organization, what their ordering frequency will be like, what their demand pattern will be like. And it's all about developing a deep understanding of customer needs and a deeper relationship with customers. As a way to start this, you can list and categorize the sources of different demand. Different categories of customers might require slightly different things. And then you can try and also identify if there's variation in the demand over different time periods. So what's the variation look like week by week, day by day, or hour by hour as appropriate? So what you will find is that most organizations have some sort of pattern of demand, and you can chart those demand patterns visually then to get a better understanding. So for example, in fast food restaurants, for example, their demand pattern will vary throughout the day. So it's hour by hour. And some fast food restaurants actually schedule activity in 15-minute increments. So you could start at, your shift could start at 8:15 and then run for a number of hours and then finish at 11:45 or something like that. Similarly, in call centers, their demand will vary at different times throughout a 24-hour day, and they will schedule their workers in the call center operators, to try and match the peaks of demand patterns throughout the day. So generally, if you can smooth your demand to better the flow, but demand is rarely smooth. So what we mean by smooth is that it's a constant level of demand, so the same level, same pace of demand. And that's generally not the case. It can be the case in some very stable organizations. So for example, in the automobile industry, then they typically have pretty good forecasts of what general demand levels will be for automobile from year to year, month to month, etc. And because of that, then they can operate on fixed schedules in the short to medium term to try and match that demand, and then they will tweak those schedules then if they identify that forecast might be looking as if it's inaccurate, and adjust the schedules accordingly. But because the pace of the demand it would kind of vary week to week rather than day to day, they have much better control over their planning and scheduling, and they can organize their operations to match that demand pattern. What's really important from the concept of leveling demand is that you don't do anything that will cause demand fluctuations. So you want to minimize demand fluctuations that might be caused by your own actions. And sometimes organizations can do this without realizing it. So for example, in holding sales at a particular end of month, maybe that will inflate customer orders at that particular time of month, but will cause, if you like, peaks and troughs in demand then throughout the rest of the month, because of that introduction of the sale period. So you're artificially creating a spike in demand that will have an impact on the demand pattern in other times for the organization. Similarly, organizations can cause fluctuations in demand by not scheduling processes at the same rate in terms of customer demand. So you schedule one particular process to produce 150 units per day, for example, and a downstream process is only scheduled to produce 100 units a day. So you're automatically going to have disruptions to flow there because they're actually scheduling these processes that are part of the same value stream at different rates, and that will cause disruptions to flow. Now, a critical calculation that's important and a critical concept in understanding demand and demand patterns is this whole concept of takt time. So this is a fundamental concept relating to the regular uniform rate of progression of products through all stages from raw materials to the customer, and it deals with services as well. So if you like, this is the drumbeat cycle of the rate of flow of products. So if we've got a process or a value stream that's manufacturing products or providing services to meet customer demand, the takt time is how much time you have to produce 1 unit of product. So the rate at which you produce 1 unit of product, that will enable you to meet your average demand for a particular period of time, be it an hour or a day. So let's have a look at the formula for that. So our takt time is the available work time divided by the average demand per day. So you're looking at the total available work time in a particular day in seconds, and then divided by the average demand per day. Now the period of time can change. It could be done on a weekly basis or a monthly basis. But for this example, we're just taking a day as the unit of time. So if we take an example here of a company, ABC Limited, it manufactures widgets. Okay, it's got an estimation of its average daily demand based on its forecast and activities. And they've worked out that this average daily demand is going to be, roughly speaking, 720 units per day. They work an 8-hour day, and that excludes breaks and lunch. So they've got 8 hours of available working time each day. And if we work out that then using the formula that we've looked at, so above the line there, you've got your available working time per day, which is going to be 8 hours by 60 minutes by 60 seconds, giving us 28,800 seconds. So that's the figure that goes above the line. And then below the line, then we've got our average daily demand. So it's the amount of time available divided by the average daily demand. In this case, the average daily demand is 720 units per second. Oh, sorry, per day. 720 units per day. So if we look at that, 28,800 seconds, and then divide it by those 720 units per day, and we've got to make 1 unit every 40 seconds to meet that daily demand. So that means 1 unit has to be coming off the production line, or our operations have got to provide, if you like, a service, then if it's a service organization, every 40 seconds to meet the daily demand. So in order to meet that demand rate, then ABC Limited must produce 1 unit every 40 seconds. So if we can work out a takt time calculation, then we can kind of figure out how our operations need to be timed or paced in order to meet our demand rate. Now, what's important to realize is that variation will always occur in operations. So if we want to produce 1 unit every 40 seconds, we might have to factor in for variation. So we might try and produce 1 unit maybe every 35 seconds to give us a 5-second buffer there in order to meet our daily demand. Okay, so a very, very simple example. I'll put some links up on Moodle as well to explain the concept of takt time in a little bit more detail. What's also important to realize that takt time is the available time is only the actual time after allowing for planned stoppages. So if you've got an 8-hour working day and you also have planned stoppages for maybe equipment maintenance or for planned comfort breaks or lunch breaks, you don't factor in any planned stoppages because that's not available time for working on producing product or providing a service. And our demand is the average sales rate plus any extras. Okay, and sometimes we have kind of test parts or anticipated scrap. So if a customer demands 1,000 units, but we know every day if we produce 1,000 units, we're going to have maybe 10 units of scrap, or we're going to have to run off maybe 5 test parts for every 1,000 units, then we need to plan that demand to factor in those test units and that scrap. So rather than putting in the average daily demand of 1,000 units, we put in 1,015 units to account for those test parts and our anticipated scrap. So basically, you're flexing the figure above the line and below the line depending on your knowledge of how your operation actually functions. Okay, so we're changing our time, we're flexing our time to allow for planned stoppages. We're flexing the demand figure based on if we know we're going to have some test parts or maybe some scrap parts or indeed defects in the process. So we've looked at working with customers and understanding demand patterns. Then we want to look at working with suppliers. So suppliers are really critical as well because they will deliver inputs such as materials, components, and other resources to the organization. And the organization then converts these inputs into outputs and products and services that add value for the customer. So if you think about any organization, be it in manufacturing, there's going to be inputs such as raw materials, electricity and power. A lot of manufacturing plants will use a lot of water supplies. They'll use other maybe components that are pre-manufactured by other organizations, and so on. And similarly in finance and office-based organizations, you're going to have lots of paper supplies. You're going to maybe have suppliers of software systems or databases or suppliers of general office supplies, etc. So every organization is going to have suppliers that use inputs in order to run their operations effectively. So what's critical from a lean perspective is we want to try and achieve a dependable, reliable supply of quality materials. And this enables us to plan and schedule our work activities. So it's vital for the smooth functioning of our operations. So the more we can rely on our supplies, we know how much materials, how much inputs are going to be supplied, at what frequency, at what cost, at what time, the better we can plan our organization's operations. So by improving the frequency of supply, we can reduce the need to keep large stocks of inputs on site. And some lean organizations would have suppliers that would supply daily or even more regularly than that. They would deliver to the site. Toyota is renowned for working with its supply networks and often encourages suppliers to co-locate next to their manufacturing facilities so they can get a ready stream of supply of components and inputs direct to their manufacturing floor on a regular basis. And sometimes organizations will encourage suppliers to deliver to the point of use. So rather than delivering to a warehouse that the organization has, they actually deliver straight to the manufacturing line or to the operations if it's a service organization. And that can reduce your inventory waste. So they provide regular deliveries. Okay, so locally here in Waterford, some pharmaceutical companies would encourage suppliers to deliver straight to the point of use in their organizations. So organizations like Sanofi Genzyme would have suppliers that deliver straight to their testing laboratories, etc., delivering kind of things like pipettes and other consumable materials that will be used in their testing activities. We can also work with suppliers to improve the quality of their inputs. So if we can rely on suppliers to deliver high quality inputs, it reduces the need for maybe our testing of those inputs, but certainly also reduces the potential for defect waste to occur. And this can avoid rework and scrap wastes. Okay, so you can see by working with suppliers, we're reducing a number of the different wastes that occur. So by improving supply frequency, we might have less inventory waste. By delivering to point of use, we might have less inventory waste, holding costs, and transportation waste. And by working with suppliers to improve quality of their inputs, we could have less rework, less scrap, less defects. So all these different types of wastes, the waste that we discussed previously. Just-in-time is worth considering here. Just-in-time is one of the key components of the Toyota production system, which is, if you like, quite often seen as the foundation of lean systems. And really what just-in-time is, it's a management strategy that aligns raw material orders from suppliers directly with production schedules. So companies employ this inventory strategy to increase their efficiency and decrease waste by only receiving goods as they need them for the production process, and that reduces your inventory costs. So just-in-time essentially means the materials are received by the organization just as they're needed. So in the right quantity, the right quality, and at the right frequency to enable the organization to carry out its operation schedule most effectively. But in order to do this, you really got to be able to forecast demand accurately. You've really got to be very, very good at forecasting demand. And it is used in quite a lot of organizations, but it's typically used in industries that have a lot of stability, okay, like the automobile industry. And if you're in an industry where there's not so much stability, where demand is less predictable, it becomes less attractive then to use just-in-time activities. So we might want to look at how we can actually improve flow and value streams. So really, that's the focus of this section. We're going to look at a number of different techniques. But it's important to realize that organizations can take steps to ensure they're better aligned for flow. And really what this involves is you taking a deep look at your organization's systems and trying to understand, well, do these systems inhibit flow or enhance flow? So do they prevent flow, or do they improve the chance that flow is more likely to occur? So in the rest of this section on the Moodle page for the Lean Principles module, we're going to look at some of the techniques that can be used to enhance flow. So we're going to look at 5S. We're going to look at total productive maintenance. We're going to look at SMED, or quick changeover. We're going to look at standard work, and we're going to look at designing work cells. Now we're going to look at these in kind of an overview fashion, so we're not going to go into a huge amount of detail on these, but I will provide also supporting links then on Moodle to give you more information. Now it's important to realize that you may be able to use some of these techniques in terms of making recommendations for improvements. If you're working on your continuous assessment for the module and you're trying to improve the flow in the process that you're looking at, some of these techniques may be useful. So just to conclude then, the concept of flow is central to success in lean organizations. Organizations should strive to improve the rate at which materials, work in process, and activity flows through the value stream. And there are a number of approaches and techniques organizations can use to improve flow in their value streams. And we're going to cover these in the next video presentations that will be available on Moodle for you. So I'd ask you to take time to look at those presentations, to understand them, and also to read the supporting material. So just to finish up quickly, the sources that I pulled from in developing this module are kind of listed here in terms of the key sources. I've put some other sources that I've already mentioned on Moodle as well, so make sure you browse the Moodle section and have a look at those sources also. Okay, that's it for this video presentation, and thanks again for your attention, and I hope you found the video presentation interesting and informative and indeed useful.